Hi, I'm Thomas Whiting, Stratasys Applications Engineer for Manufacturing Solutions. I'm going to show you the benefits of using FDM 3D printing technology to make metal forming dies and press brake tooling, and then I'll show you what's involved in designing them. Typically, metal forming dies are used in the manufacturing process when thin, relatively simple sheet metal parts need to be made at scale. Most of the time, these dies are machined from tool steel, which is time-consuming and expensive, especially for low-volume production. Sometimes revisions are made to the tool to account for changes needed after fit and function tests. This requires additional machining that adds time and cost to the overall project schedule. FDM 3D printing is a great alternative to machining, especially for highly complex shapes, low-volume production, and to keep production running when tools break, when they need to be replaced, or require updating. FDM 3D printed forming tools are ready in a very short time with minimal impact on the production schedule. This gives you control when your supply chain is disrupted. So the main benefits of 3D printing these tools are the speed, lower cost, and design flexibility. Tools can be printed in hours instead of weeks. Cost is lower because you're only paying for the material used to print the tool. And 3D printing's design freedom using Stratasys support material lets you easily make complex tool shapes that may be difficult and time-consuming to machine. Additionally, by utilizing FDM 3D printed tools, you can increase the number of design iterations during the development process, leading to a more refined final design in a shorter time period and at a lower cost. Based on the requirements of your forming operations, Stratasys has several high-strength thermoplastics available to choose from. Here are some considerations when designing your 3D printed metal form and press brake tooling. Create your tool using the same design philosophies used when designing metal tools. Be sure to include guide pins and stroke limiters where necessary to prevent tool damage. It's preferable to make the tools as a single 3D printed part to prevent weak spots. Under the forming pressures, an FDM tool may have a small amount of deflection that decreases or eliminates the amount of springback in the sheet metal component. We recommend designing your tool with no springback compensation and add it in, if necessary, after testing. Part orientation is important because it affects the compression strength of the final part, and it also affects surface finish of the tool, which could transfer to the formed part depending on gauge thickness. It's best to print tools with solid infill and multiple linked contours in order to increase strength. It's important to match the material to the requirements of your forming operation. Our recommendation for materials are FDM Nylon 12 carbon fiber, polycarbonate, ABS CF10, and Ultem 1010 and Ultem 9085 resins. Please refer to our material data sheets when choosing your material. 3D printing metal form tools with FDM technology isn't difficult and offers multiple benefits over making them with traditional methods. To learn more about this application or other 3D printing manufacturing solutions, contact your Stratasys representative or visit stratasys.com. Thanks for watching.